So one last example right here, and let's put this to the test. We actually looked at this curve a little bit earlier. This was our folium of Descartes. And one of the points, at least on this particular function, is the point 3, 3. And let's say we're interested in finding the slope of the line tangent to the curve at that point here. Let me see if I can draw. We want the slope of that line. What would the slope of that line be? Well, we can kind of estimate it based on sort of a visual, but let's check it out and see what we actually get. So how we're going to do it? Well, we're going to take our derivative implicitly on both the left and the right hand side of the equation. So let's do that. We would be taking, let me get a pen working here. Come on, pen. Let's take the derivative with respect to x. We've got x cubed plus y cubed minus 6xy. And we're going to set that equal to the derivative with respect to x of 0. Well, we know what happens on the right. That's going to be 0. But on the left, let's run through our terms. We take the derivative with respect to x of each term individually. We end up with 3x squared plus, and we take our derivative of y cubed, so we end up with 3y squared. But this time, because y does not match with the x in the bottom right there, we're going to say it's dy dx. Minus, and then we're going to take 6 times the derivative with respect to x of our product xy, and all of that will give us 0. Let me run through this here. 3x squared added to 3y squared dy dx minus 6 times the quantity x times dy dx plus y times dx dx, so that's just 1, is equal to 0. So separating our terms out, we've got 3x squared plus 3y squared dy dx. My d doesn't look very good there, but trust me, it's a d. Dy dx minus 6x dy dx minus 6y is equal to 0. Now, we can go through a bit of the algebra right here to isolate dy dx. I'll tell you what will happen. We're going to end up with dy dx equal to 6y minus 3x squared divided by 3y squared minus 6x. 3y squared minus 6x. And again, you see this sort of a certain kind of beautiful symmetry right here in this derivative where we're reversing the terms. But nonetheless, our job right here was to find the equation line tangent to the curve at 3, 3, which means that we first want to find our slope. So let's go ahead and find our slope right here by substituting in the point 3, 3. So at 3, 3, the derivative of y with respect to x here in this equation is going to be 6 times 3 minus 3 times 3 squared divided by, let's see, 3 times 3 squared minus 6 times 3. When we work that out, that's 18 minus 27 divided by 27 minus 18. Well, whatever 27 minus 18 or 18 minus 27 is, doesn't matter. They're just the reverse of each other. We end up with -1 as our slope, and that's actually a really nice thing for us because it kind of looks like a -1 slope right here. And if I wanted the equation of that line, in order to find it, what I'm going to do is I'll go ahead and write my equation. Let's try it with the point slope form to begin with. We would say y minus 3 is equal to our slope of -1 times x minus 3 Doing a little bit of the algebra right here to isolate y, we would have y minus 3 is equal to negative x plus 3, and then adding 3 to both sides, we're going to find our equation of our line right here would be y equals negative x plus 6. Sort of interesting that we end up with such a simple linear equation out of this huge complicated mess. But there it is. The equation of our line, tangent to the curve, at 3, 3, and our folium of Descartes. Awesome. All right, good luck.